Welcome back, viewers. So today we'll be discussing triangles, more particularly right angle triangles. To draw a right angle triangle, we can use a notebook. We can use the intersection of the margin line and any horizontal line because these lines are perpendicular lines. So at the intersection, we'll have a right angle. I am now going to draw 3 right angle triangles of various sizes. Now I am going to measure the length of the base and the length of the height of each triangle. The length of the height of this triangle is 3 centimeters. And the length of the base of this triangle is 4 centimeters. I will not measure the length of the hypotenuse yet. Moving on to the second triangle, we can see that the length of the height of our triangle is 5 centimeters and the length of the base of the triangle is 12 centimeters. And finally, the length of the height of this triangle is 11.9 centimeters and the length of the base of this triangle is 12.0 centimeters. Now let us focus on the dimensions of our first triangle. If I take its height, which is 3 centimeters, and square that, I will get a value of 9. Now if I take its base, which is 4 centimeters, and square this number, I get a value of 16. What I'm going to do is I'm going to add 9 and 16 together. So 9 plus 16 is equal to 25. When I measure the length of the hypotenuse of this triangle and I square that value, that should give me the same 25 which I just arrived here. So I'm going to take my ruler and I'm going to measure the length of this hypotenuse. And as you can see, the length of this hypotenuse is 5 centimeters. So if I square that 5, what do I get? I also get 25. Did you realize what was done here? I took the length of the height, I squared that value, I took the length of the base, and I squared that value. I added the squares of these two values, and it is the same as if I took the measurement of the hypotenuse and square its value. If I measured the length of the hypotenuse, then square that value, and I got a number other than 25, then that would only mean that this is not a right angle triangle. The only way this can be a right angle triangle is only if the hypotenuse is 5 centimeters long. Now, what about our second triangle? Will this also hold true? So the height of our second triangle is 5 centimeters. Let's square that value. 5 squared is equal to 25. The base of this triangle is 12 centimeters. Let's square that value. 12 squared is 144. Now let's add these two. 25 plus 144 is equal to 169. Now I haven't measured the length of its hypotenuse, but when I measure the length of its hypotenuse and then I square that value, I should get the same 169 that I have arrived to. So let us do that. As you can see, measuring the length of its hypotenuse gave me a length of 13 centimeters. Now, if I square 13 centimeters, I get 169. What this is saying is that the square of the height plus the square of the base is equal to the square of the hypotenuse. Now you might be thinking, okay, I've only been using whole numbers. What if I use decimal values? So let's refer to our next triangle. Now 11.9 squared is 141.61. 12.0 squared is 144.0. If I add 141.61 with 144.0, I get 285.61. Now, if what I said previously is correct, if I measure the length of the hypotenuse of this shape, then square its value, I should also get the same 285.61. So, as you can see, using the ruler to measure the length of its hypotenuse, I get 16.9 centimeters. Now, when I square 16.9, which is 16.9 times 16.9, I get 285.61. This is a pattern that you can observe in all right angle triangles. So long as a triangle contains a right angle, if you take its height, you square its value, then take its base, you square its value, you add the two together, that should be the same as squaring the length of its hypotenuse. Now, in mathematics, we love the use of symbols to make things simpler and easier to remember. So, we'll use the letter A to represent the height of our triangle. We'll use the letter B to represent the base of our triangle. And we'll use the letter C to represent the hypotenuse. So, we can represent this as A squared plus B squared is equal to C squared. And this right there is the Pythagoras Theorem.